Hello! Yes, and welcome to our Objective 1.10 sample problems. Objective 10 says I can evaluate and graph a piecewise function, so let's do some evaluating. Let's look at letter A here, h of 4. I'm going to find h4. All right, h of x is right here. When I have 4, it'll go right in there. Okay, so that means I will have h of 4 equals the square root of 4 minus 4. All right, so now that I'm looking at that, I get square root of 0, which of course is 0. H of 4 equals 0. Fantastic. What about g of negative 2? Well, let's find out. G of negative 2, which equation will I plug g of negative 2 in? Here's g negative 2 is going to go into this middle one here. And the middle one, since it's less than or equal to negative 2, is just 6. So I can just say g of negative 2 equals 6. That's all I need to do for that one. F of 5. Okay, so looking at our f function here, 5 is greater than or equal to 0, so it'll go into the bottom equation. So I'll say 3 times 5 minus 5. That is 15 minus 5. So f of 5 equals 10. Very good. All right, h of 7. Let's figure out what's happening here. H of 7 is greater than or equal to 4. I'm in function h here. H of 7, I would say, equals the square root of 7 minus 4, which is the square root of 3. And we can just leave our answer like that since that is an irrational number. H of 7 equals 3. G of 0. G of 0. So 0 is between negative 2 and 1. So this one, again, is just 6. Very nice. H of negative 3. Well, negative 3 is definitely less than 4. So I will say this equals the absolute value of negative 3 minus 5. Negative 3 minus 5 is negative 8. The absolute value of negative 8 is just 8, because negative 8 is 8 units from 0. All right, now let's see if I can zoom this out a bit so I can see everything at once. Let's see how this works out. All right, f of 12. Well, 12 is definitely greater than or equal to 0. So I will say f of 12 is 3 times 12 minus 5. 3 times 12 is 36. 36 minus 5 is 31. So f of 12 equals 31. Very good. G of 1. Oh, finally, one that's not just 6. Notice, greater than or equal to 1. So that's the one I'll use. I'll say it's the opposite of 1 minus 6. I'm plugging it in for that negative x up there. So negative 1 minus 6 becomes negative 7. So g of 1 equals negative 7. Now, h of negative 1/2. Why you got to be mean like that, Mr. Carter? Throwing in some fractions. All right, h of negative 1/2. Well, negative 1/2 is definitely less than 4. So I would say this is the absolute value of negative 1/2 minus 5, which would be negative 5.5 or negative 11/2. The absolute value of that is just 11 over 2. So h of negative 1/2 equals 11 over 2. Hopefully we're feeling a little more confident with evaluating piecewise functions. Let's look at graphing piecewise functions. So looking at letter K here, h of x equals, we have the absolute value of x plus 1 when x is less than 4, and the square root of x minus 4 plus 1 when x is greater than or equal to 4. Excellent. So let's go ahead and make some tables. So we have the absolute value of x plus 1 and the square root of x minus 4 and then plus 1. Our domain restriction is at 4. I like to place that dashed line on there, a dotted line right on that domain restriction. So for the absolute value, we want values of x that are less than 4. So we can go 4, 3, 2, 1, go from there. And then for our square root function, we want values that are greater than or equal to 4. So we'll go 4, 5, and then let's do 8 as well. The reason I did that will become apparent here in a sec. So as I plug in these values, the absolute value of 4 plus 1 is 5, of 3 plus 1 is 4, 2 plus 1 is 3, 1 plus 1 is 2, square root of x plus 4, well 4 minus 4 is 0, 0 plus 1 is just 1. 5 minus 4 is 1, the square root of 1 is 1, 1 plus 1 is 2, 8 minus 4, the square root of 4 is 2, 2 plus 1 is 3. So as I plot these points, I can think, okay, here is my table of points, let me plot them. There's another way we can do this. Combining with our information from last objective, we can look at this from a transformation standpoint. So the absolute value of x plus 1 is a function that was moved left 1. Absolute value function moved left 1 and going from there. Now notice that corresponds to the points that we found for that table. All right, the square root of x minus 4 plus 1 is a square root function that's been moved right 4 and up 1. All right, so it would be right here, it's going to have that closed circle since it's greater than or equal to. And then we can start that function from there. There we go. This one will have the open circle since it's strictly less than 4. And there we go. That'll go off in that direction. Very good. Notice there's no arrow here because it stops at that dashed line. All right, there's letter K. Let's look at letter L, K of x here. So we have 3 when x is less, well, let's do these. Negative 6 is right here. And 3 is right here. Let's do these using transformations. I think that'd be a good way to do this. So 3 if x is less than negative 6. So right away, 3 we know is going to have a open circle because it's strictly less than negative 6, and it's just going to stay on that 3 line going all the way to the left. Negative 2x when negative 6 is less than or equal to x is less than 3. Well, negative 2x would have an intercept of 0, and it'd go down 2, right 1, down 2, right 1. Strictly less than 3, so we'd have an open circle there. And this would just continue like this. Now, in this case, it goes off the graph. That's fine. The important thing here is I wouldn't put an arrow that it's going off the graph. You can if you want, but that arrow might imply that it continues going that way. I think just drawing it like that is just fine. And then our absolute value function that has been moved right 4, down 2, and then stretched by a factor of 2. So instead of going over 1 and up 1, it'll go over 2, up 2 and over 1, up 2, over 1, all the way here. And there we go. That you can throw an arrow on because it's going to continue out that way. This is that closed circle because it's greater than or equal to 3. And there's a way to do it using our transformations where we didn't have to make the table for each one. All right, last, whoa, why is that moving? Whoa, 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 crazy. I don't know what's going on. I don't know what's happening. Can I move it now? No? Okay. That was weird. Let's try letter M. Technology is having fun today. That's okay. Okay, so we have negative 2 and 5 are our domain restriction values. Negative 2 is right there. 5 is right there. Go ahead and make those dashed lines, dotted lines on there. To the left of this negative 2 line, we have an absolute value function that's been moved left 4 from 0, 0, down 3, and then stretched by a factor of 2. And we know we're going to have an open circle because the domain restriction is strictly less than negative 2. So I can go ahead and do that one. And then we have negative 1/2 x plus 2 between negative 2 and 5. So negative 1/2 x plus 2 has a y-intercept of 2 and goes down 1, right 2, down 1, right 2, or up 1, left 2. This one will have a closed circle there, and we'll have an open circle where it would cross at 5. There we go. That's the most unstraight line I think I've done in a really long time. Let's try that again. There we go. And then we have the negative square root of x minus 5 minus 2 to the right. So this one has been shifted right 5, moved down 2. we'll have a closed circle there. And then instead of opening up, it'll open down like so. And there we go. And there is that piecewise function. All right, hopefully we're feeling more confident graphing piecewise. Hopefully we're feeling confident with everything from Unit 1. This was our last sample problems video. This is our last objective. And for the last time this unit, this is Mr. Carter signing off. I'll see you next time.